In some of the short programs we've looked at in this course, I've iterated over the items in an array just by adding 1 to the pointer variable. For example, here I add 1 to pi. That's a pointer to an integer in order to move to the next element in an array of integers. And here I iterate to the next character in a string by adding 1 to the pc variable, which is a pointer to char. But wait a minute, since the value of a pointer is a number that represents an address in memory, why does adding 1 to a pointer have the effect of moving it to the next element in an array? Maybe it's because it just increases the value by 1 byte, so it moves the pointer 1 byte in memory, and that's where the next element in the array is stored? But no, that simply doesn't make sense either. I know that my C compiler on Windows needs 4 bytes for an integer. So it would seem that when I add 1 to my int pointer, I actually move 4 bytes in memory to the next int in my array. To understand what's really going on here, we need to look at how pointer arithmetic is done in C. Here in my Address Arithmetic 1 sample program, I create an array of 4 integers. Since I've declared the array's size at the time of its declaration, memory will automatically be allocated for it, so I don't need to call the malloc function. In this for loop, I initialize the array with 4 integers from 0 to 3, and I set the p pointer to point to it. That is, by assigning the array a to the pointer p, I set the value of p to the address of a. Now let me run this code so you can see the results. First, I show the address of the array a and the value of the pointer p, and they're the same, as you'd expect. Then I dereference p, which shows me the integer to which it points. That's 0, the first element of the array. The address of the array never changes, so this number remains the same throughout my program. Now I add 1 to the pointer variable p. By default, pointer values are shown in hexadecimal, and that's this number here. But for clarity, I've also shown it in decimal format, though it's possible that your compiler may object to that. And look, even though I added 1 to the pointer, its value has increased by 4. So it points to an address in memory that's not 1 byte, but 4 bytes further along from the start of the array. In other words, adding 1 to the pointer has increased its value by the size in bytes of a single array element. And now it points to the second element of this array, and that's the integer 1. Why does adding 1 to the pointer increase its value by 4? It's because C knows that my array contains ints. That's how I've declared it. It knows an int takes up 4 bytes, and so it knows that when I add 1 to my pointer, what I mean to do is to increase the value of that pointer, that is, to increment the address that it stores by however many bytes are needed to move to the next element of the array. Now I add 2 to the pointer, and I can see that its value, the address to which it points, has been increased by 8. That is, 2 times the size of an int. Previously it pointed to the second element, now it points to the fourth element, and that's the integer 3. And finally, I decide to see what happens if I increment the pointer once again. It already points to the final element in the array, so what will it point to now? Well, the answer is, your guess is as good as mine. It points to whatever happens to be in the memory 4 bytes after the end of the array. I shouldn't really be trying to access that memory at all. So in a real-world program, you would need to check very carefully that any pointer arithmetic operations only take you to some known memory location, such as an index in an array which you have previously allocated and initialized.